about. So we are going to have now our case number 4, determining if a counting number can be expressed in a specific number of terms, particularly odd number of terms. The sum of consecutive numbers is 115. Can 115 be expressed of 5 terms and 7 terms? So we are going to first have the 5 terms. Since there are 5 terms, we are going to have x plus the quantity of x plus 1, x plus 2, x plus 3, x plus 4, and x plus 2 as our median. So we are going to use the formula for odd numbers, which is x is equal to n multiplied to m. So we are going to substitute all the given, which is 115 as the sum, and 5 as the number of terms, and x plus 2 as the median. So 5 times x plus 2 is equal to 5 plus x plus 2 is equal to 5x plus 10. So we're going to find the additive inverse of 10. We will have 105 is equal to 5x. Divide both sides by 5 so that x will remain. We will have x is equal to 21. Now we are going to have 7 terms. This same process, we are going to find x plus 1 up to x plus 6. We have x plus 3 as our median. So now we will have 115 is equal to 7 multiplied to x plus 3. 7 times x plus 3 is equal to 7x plus 21. Then, we will now find the additive inverse of 21. 115 minus 21 is equal to 94. And divide both sides by 7 so that x will remain. We will have 94 over 7. And it is a fraction. So based on the cases we presented earlier, a counting number can be expressed in specific number of terms if their x is a counting whole number. So let us say that you are going to express 10 in specific number of terms, such as 6 terms, 5 terms, 4 terms, or 2 terms. So if their result, or if their x is a whole number, therefore it can be expressed in that specific number of terms. And our x here represents as our first term. So if it is not a counting whole number, therefore it is not, or it cannot be expressed in that specific number of terms. So based on the results, we can say that on case number 3, the counting number 10 can be expressed as the sum of 2 or more consecutive counting whole numbers. However, the sum 10 cannot be expressed in 6 consecutive counting number, but rather the 10 counting number can be expressed in 4 specific number of terms, such as 1 plus 2 plus 3 plus 4. It has its first term, which is our x, which is 1. On the other hand, on case number 4, the counting number 115 can be expressed as the sum of 2 or more consecutive counting whole number also. It can be expressed as the sum of 5 terms, 5 consecutive counting numbers, yet it can be expressed as the sum of 7 consecutive counting numbers. Since if you're going to use 7 terms, the result would be, our x would be a fraction. While if we are going to use 5 terms, our x would be a whole number. And as stated in the conjecture or in the discussion, that if x is a whole number, then therefore it can be expressed in that specific number of terms. Okay, for the case number 5, we will have a sum can be expressed in specific number of terms and ways. Given a sum that is not 1 and 2 raised to the power of n, and it is either an even or an odd number of terms, but it cannot be expressed in that number of terms, or its result is not a whole number, its x is not a whole number, therefore that specific sum cannot be expressed in that specific number of terms. For example, the 10, it's if you're going to use 6 terms, its x is 5 over 3. On the other hand, if you're going to use 4 terms, its x is 1. Therefore, it cannot be expressed in 6, but it can be expressed in 4. Let's have another example to prove our case. The sum of consecutive counting numbers is 9. Can 9 be expressed as the sum of 2 or 3 terms? Since there are only 2 terms, we are going to use x plus 1. And our median would be the both, x plus 1. So we're going to substitute all the given, 9 as its sum, 2 as its number of terms, and x plus 1 as its first and second median divided by 2. So we are going to cancel 2, so it will remain 2x plus 1. So 9 is equal to 2x plus 1. So we are going to find the additive inverse of 1. 9 minus 1 is equal to 8. 8 is equal to 2x. We are going to divide both sides by 2 so that x will remain. Then we will have x is equal to 4. It is a whole number. Note that it is a whole number. Next is, we are going to find using 3 terms. X plus 1 plus x plus 2. So the median is x plus 1. So the formula we are going to use is x is equal to n multiplied to m. So substitute all the given terms. 9 is equal to 3 multiplied to x plus 1. So we will have 3x plus 3 is equal to 9. So find the additive inverse of 3. We will have 9 minus 3 is equal to 3x. Then we are going to subtract 9 minus 3, 6. 6 is equal to 3x. Divide both sides by 3 so that x will remain. We will also have x is equal to 2. Therefore, we can say that 9 can be expressed in 2 terms and it can also be expressed in 3 terms since their x's are whole number. But if their x's are fraction, decimal, 0, or a negative number, therefore it cannot be expressed in that specific number of terms since we are just focusing on counting whole numbers and it does not include negative numbers. It only includes positive. For our example number 2, we have the sum of consecutive counting number is 15. Can 15 be expressed as a sum of 2, 3, 4, and 5 terms? We have 4 terms here, the 2, 3, 4, and 5. So in the first 2 terms, the same formula, the same process, and its x is 7. Next is 3 terms, same formula, same process. We have x is equal to 4. Next is 4 terms, same formula, same process. Its x is 13 over 4. And same formula and same process for 5 terms, we have x is equal to 1. So, which number or which term 15 cannot be expressed? So we can say that 15 cannot be expressed in 4 terms because its x is 13 over 4 and it is not a whole number, yet it is a fraction. So in 2 terms, 3 terms, 4 terms, 3 terms, 4 terms, and 3 terms. So in 2 terms, 3 terms, and 5 terms, we have an x which is a whole number. Therefore, 15 can be expressed in 2 terms. 8 plus 7. 15 can be expressed in 3 terms. 4, 5, and 6. And also, 15 can be expressed in 5 terms. 1, 2, 3, 4, and 5.